All right, guys, it is time to move on to section 2.6. This is moments and centers of mass. So what this is this is another way we can use calculus 2 stuff and calculus 1 stuff and things like that to help us with things outside of, a regular math class. So like I said, last class, this is real world stuff, which by real world, again, I don't necessarily mean you are going to use this at the grocery store, but if you get a job outside of math, you are going to need to know this. A lot of people, they want to know, when am I going to use all of this stuff? And there are jobs out there in which you are going to need to know this. And so this is going to be helpful in that. Basically, what it is if I have a bunch of points, and each point has each point, if it has a mass, I'm going to want to learn where the center of that is, okay? Because, of course, if every point has some kind of, like, let's say, for example, on this whiteboard, I'm going to put a bunch of points here. So, like, let's say this one is like 2 grams. This point is like 5 grams. This point over here is 3 grams. I want to know where the middle of all of that is. And that is what we are going to learn today. So let's get out our note sheet for section 2.6. We're going to start if I put those points on a straight line. So again, on a line means that if I just have a straight line, I want to be putting points on this line, is what it means. Okay. Let M1 and M2, M3, on and on up until Mn be point masses placed on the number line at points x1, x2, x3 up until xn. So what this means, M1, M2, M3, is going to be the mass for each point, and these are going to be where I am on the line, okay? Let the lowercase m be equal to the sum of the masses. So a lowercase m is the total mass for those points. And then the moment is going to be the sum of every mass times where it is on the line. So it's going to be the mass times the x. And then M2, 0.2, M3, 0.3, on and on and on. The center of all of that is going to be the moment divided by the total mass. Okay? The notation here makes it look harder than it actually is. This math is not very hard at all. Let me show you with example number 1. Suppose 4-point masses are placed on the number line as shown here. M1 is going to be 30, placed at x1 equal to negative 2. M2 is going to be 5 with x, this should say x2, so sorry about that. X2 at 3. M3 is going to be 10, placed at 0.6. M4 is going to be 15, placed at the point negative 3. And I want to find the moment and then use it to find the center of the mass there. So once again, what this means on the number line, this is example number 1. Let's put 0 here. My first point is placed at negative 2. So negative 2 is right here. And that mass is 30 grams. Or sorry, 30 kilograms. My next one is placed at x2 equals 3. So 1, 2, 3 is right here. Put a point there. The mass is 5. My third point is at 6. 1, 2, 3, 4, 5, 6. Placed here with a mass of 10. Let me get a different marker. And then my fourth and final point is placed at negative 3. 1, 2, 3. And that mass is 15. And I want to know where the center of that is. So first things first, I need the total mass. So the total mass, remember, is just the sum of all of the masses. The first one is 30. Second one is 5. Third one is 10. Fourth one is 15. So I just need to add them up. 30 plus 5 is 35, plus 10 is 45, plus 15 is 60. So that is the total mass. Now I need to find the moment for these points, which is the sum of every mass times where the point is. So for the first one, my mass is 30, and that point is at -2. Plus, my next one is 5, my mass is 5, my point is at 3. My next one, the mass is 10, and the point is at 6. And then the last one, my mass is 15, and my point is at -3. So now I just need to add that up. 30 times -2 is -60. 5 times 3 is 15. 10 times 6 is 60. 15 times -3 is -45. -60 plus 15 is -45, plus 60 is 15, minus 45 is -30. So the moment is going to be -30. So to find the center, which is x bar, the center of mass, that's going to be the moment divided by my total mass, that's the capital M, a lowercase m, moment over mass. My moment is -30, my total mass is 60, so the center is going to be at -1/2. So what this means is the center of these points is going to be at x is equal to -1/2, which is right here. So what this means is I could put the center right here, and that's going to balance out all of the weights I have there. So the question asks for the moment. The moment was -30, and it also asks for the center of mass. The center of mass is -1/2. Easy as that. So these actually, so far, this one doesn't have any calculus stuff yet, right? This is all just knowing how to add, so it's not that bad. Let's go on to example number 2, which is kind of the same thing. Suppose 4 point masses are placed like this. Mass is equal to 12 at the point at -4. Another mass at 12 at the point 4. Another mass of 30 at the point 2. And then another mass of 6 at the point -6. So let's do the same thing. So again, let's find our total mass. This is the sum of all the masses. The masses are listed here: 12, 12, 30, and 6. So 12 plus 12 plus 30 plus 6. 12 plus 12 is 24, plus 30 is 54, plus 6 is 60 again. Didn't mean to do that, but that's okay. And then the moment is going to be the sum of the masses times where the point is. So the first one is 12 at -4. And then 12 at 4. So 12 times 4. And then 30 at 2. And then 6 at -6. So let's work that out. 12 times -4 is -48. 12 times 4 is +48. 30 times 2 is 60. 6 times the -6 is -36. -48 and 48 cancel out, so that's good. 60 minus 36 is going to be 24. So the moment is 24. So now to find the center, that's just the moment divided by the mass. The moment is 24. The mass is 60. Both of those have a factor of 12. So that's going to be 2/5. So the center of mass there is 2/5, and the moment is 24. So when it's on a straight line, it's not too bad. There's really not a whole lot of work you've got to do there. So that's if it's on a straight line. Let's look at it if it's not on a straight line, but like what I did with the whiteboard a while ago, if it's on a plane. Okay. So if it's on a plane, the work is kind of the same. There's just something important to notice. Okay. So let's look at the formula for the center of mass objects in a plane. So again, this means it's not just in a line. It could be all over a 2D space. Okay. So again, let M1, M2, M3 up until Mn be the masses placed in the xy plane at points x1, y1, x2, y2, x3, y3 up until xn, yn. So this is the same kind of thing as what we had up here. The difference is that these are points now, meaning I have x and y. Okay. Still, let M be the sum of every one of the masses I have here. That's the same thing. The moments, not going to work how you would assume, okay? So the moment for X means let's assume X is like a constant. What's happening to the Y's, okay? So the moment for X, I'm going to do every mass times every Y, okay? Again, because the moment for X means if I leave the X, what's happening to the Y points, okay? So every mass times every Y, and the same thing, the moment for the Y's is going to be every mass times every X, because if Y stays, what happens to the X's? So the moment for X uses Y, the moment for Y is going to use X. So the center of mass there, again, since these are at a point, the center is going to also be a point. For the X part, do the moment about Y over my mass. For the center for the Y, do the moment for X divided by my mass. So let's do some examples there. Example number 3, suppose 3 points are placed on the plane like this. The mass of 2 is placed at -1, 3. A mass of 6 is placed at 1, 1. And then a mass of 4 is placed at 2, -2. So let's work this out. First things first, our total mass is just going to be the sum of the masses. 2, 6, and 4. So just add up 2, 6, and 4. 2 plus 6 is 8. 8 plus 4 is 12. So my total mass is 12. Now I'm going to do the moment about X first. Remember, that's the sum of every mass times where I am on the Y. So for this one, 2 is at Y equals 3. 6 is at Y equals 1. And 4 is at Y equals -2. So 2 times 3 plus 6 times 1 plus 4 times -2. Again, because I just do the mass times what the Y is. And that's what I did. Mass times Y, mass times Y, mass times Y. 2 times 3 is 6. 6 times 1 is 6. 4 times -2 is -8. 6 plus 6 is 12. 12 minus 8 is 4. So now do the moment about Y, which is going to be the sum of the masses times every X. So again, let's look at our masses. Mass of 2 placed at X is equal to -1. Mass of 6 placed at X is equal to 1. Mass of 4 placed at X equals 2. So 2 times -1 plus 6 times 1 plus 4 times 2. 2 times the -1 is -2. 6 times 1 is 6. 4 times 2 is 8. -2 plus 6 is equal to 4. 4 plus 8 is 12. So now that I have all of that, I can find the center for x. Remember, the center for x is the moment about y divided by my mass. My moment about y was 12, and my mass was 12, so 1. And then the center of mass for y is going to be the moment about the x over my total mass. The moment for x was 4, my total mass was 12. 4 over 12 is 1/3. So the center of mass there is at the point 1, 1/3. Something I see a lot is that people switch this part right here. So like they think since it's the center of mass for the x, I should do mx, but that's not right. For the center of mass for x, make sure we do my and then switch them here. Example number 4 is going to work the same exact way. Suppose 3-point masses are placed on the xy plane as shown here. Mass 1 is 5, placed at 2, -3. Mass 2 is 3, placed at 2, 3. And mass 3 is 2, placed at -3, -2. Find the center of mass. First, the total mass, the sum of every mass. The masses are 5, 3, and 2, so 5 plus 3 plus 2. 5 plus 3 is 8, plus 2 is 10. So the total mass is 10. Now let's do the moment about x. That's going to be the sum of the masses times every value of y. So we have 5 placed at y equals -3, 3 placed at y equals 3, 2 placed at y equals -2. So mass times y plus mass times y plus mass times y. 5 times the -3 is -15. 3 times 3 is 9. 2 times the -2 is -4. -15 plus 9 is equal to -6 minus 4 is -10. So then do the moment about y. That's going to be the sum of the masses times the x. 5 times -2, 3 times 2, 2 times -3. That's what we're going to do there. Five times the -2 is -10. 3 times 2 is 6. 2 times the -3 is -6. -10 plus 6 is equal to -4. Minus 6 is -10. So the center of mass for x is the moment about y over my total mass, which is going to be -10 over 10, so -1. And then the center of mass for y is going to be the moment about x over my mass, which is -10 over 10, which is also equal to -1. So the center of mass here is -1, -1. So that's how I would do this if my the masses are placed at a point. However, they are not always just a point. Sometimes it's going to be a graph. So like I might say the graph of x squared has a mass of a certain amount of stuff, right? When this happens, there's something else we've got to do. And the formulas for this are kind of complicated, so let's go through them one at a time. Number 1, again, so it's a thin plate, meaning like a graph, that kind of stuff. The total mass is going to be rho, where rho is going to be the density, just like it was in section 2.5, times the integral from a to b of f of x dx. If they do not tell you what the rho is, assume rho is equal to 1. Okay, once again, if they do not state what the rho is, assume rho is equal to 1. Okay. Hint, for those of y'all taking my class, rho is always 1, so that's really helpful. So the moment about x is equal to rho. Again, if they don't state rho, assume that that is 1. Integral from a to b of the function squared over 2 dx, and the moment about y is going to be rho times the integral from a to b of x f of x dx. And then still the center of mass for x is going to be the moment of y divided by my total mass, and the center of mass for y is going to be the moment of x divided by the total mass. So let's practice that. Example number 5, let R be the region bounded above by the graph of the function f of x equals the square root of x, and below by the x from 0 to 4. Find the centroid, which is the same thing as the center of the mass. So again, they do not state what the rho is, so I'm going to assume rho is equal to 1, which is really nice and makes this not as hard. Okay. First thing, total mass. Total mass is equal to rho integral from a to b of f of x dx. Remember, we said if they do not state the rho is equal 1, so our rho is going to be 1. Integral, my bounds for this problem are from 0 to 4. So 0 to 4 of the function, which is going to be the square root of x. Remember, we have said this, that it might be helpful just to write as x to the 1/2 so that I can use the power rule. So that's what I want to do. This isn't very hard to take the antiderivative of. Remember, I'm going to add 1 to the power. 1/2 plus 1 is 3/2, and then divide by that new power. Dividing by 3/2 is like saying times 2/3. So we're going to do that from 0 to 4. Plug in our top bound first, so plug in a 4. 2/3, 4 to the 3/2 minus, then plug in the bottom bound, which is 0. 4 to the 3/2, that's like taking the square root and then raising it to the third. The square root of 4 is 2. 2 to the third is 8. So that's 2/3 times 8. 0 to the 3/2 is equal to 0, so that's nice. Don't have to even really worry about that. 2/3 times 8 is 16/3. So my total mass is going to be 16/3. So now I'm going to do the moment about x. Our formula for the moment about x is rho integral from a to b of the function squared over 2. Once again, our rho is going to be equal to 1. So it's going to be integral. Our bounds are still 0 to 4. My function is the square root of x. This divided by 2, I can pull it out front as a 1/2. Integral from 0 to 4. Square root of x squared, very nicely, is just x. Very nice. The antiderivative of the x, remember we're going to raise our power by a 1, so it was 1, so now it's 2, divided by my new power. 0 to 4. Then plug in the top bound, that's going to be 1/2. 4 squared over 2 minus the bottom bound, which is 0. So 1/2. 4 squared is 16. 16 over 2 is 8. 0 squared is 0. 0 divided by 2 is 0. 1/2 times 8 is 4. So the moment for x is going to be equal to 4. Now do the moment about y. Rho integral from a to b of x f of x. Rho is equal to 1, so that's integral from 0 to 4, x times the function, which is square root of x. We did a lot of these in an earlier section. I don't remember which section it was, but we did a lot of these. I want to say 2.3. X times the square root of x is like saying x to the 3/2. So this is integral from 0 to 4 of x to the 3/2 dx. Once again, to take the antiderivative, we're going to add 1 to the power. 3/2 plus 1 is 5 halves and then divide by that. Dividing by 5 halves is like saying times 2/5. 0 to 4. So plug in our top bound. 2/5 times 4 to the 5 halves. 0, if I plugged it in, would be equal to 0. So I don't even have to really worry about that. 4 to the 5 halves, that's like doing the square root to the 5th. The square root of 4 is 2. 2 to the 5th is 32. 2/5 times 32 is 64/5. So the moment about y is equal to 64 over 5. So now, to find the center of mass for the x, sorry I ran out of room, I'm going to have to get another board. Center of mass for the x is going to be the moment about y divided by my mass. My moment about y is 64/5 divided by my total mass, which is 16/3. To divide two fractions, remember I do keep, change, flip. So 64/5 is going to be what I keep. Change means I'm going to make this times. Flip this is like saying times 3/16. Reduce this as much as I can. 64 over 16 is really nice because that simplifies to 4. 4 times 3 is 12 over. All I have left down here is a 5. So 12/5. And then the center for y is going to be my moment about x divided by my total mass. My moment about x we said was equal to 4 divided by my total mass, which was 16/3. Once again, keep, change, flip. 4 is like saying 4 over 1 times, flip this, 3 over 16. 4 over 16 reduces to 1/4, so I get 3/4. So the centroid, the x value is 12/5. The y value is 3/4. So this still isn't too terribly bad. It's just having to do 3 different steps to get what I want, So but it's still not too terrible. Example number 6 works a lot the same way. Let R be the region bounded above by the graph of the function f of x equals x squared and below by the x from 0 to 2. Find the centroid. So I'm going to do the same thing, but this time my bounds are 0 to 2 and my function is x squared. So let's do the same thing. Total mass is rho integral a to b f of x. They do not specify what the rho is, so I'm going to assume it is equal to 1. So I'm going to do integral a to b is going to be 0 to 2 because that's what the bounds are. That's what it says. So 0 to 2. And my function is x squared. Take the antiderivative of x squared. Remember, we're going to add 1 to the power and then divide by that new power from 0 to 2. I can plug in a 2. 2 to the third is 8, so that's 8/3. And if I plugged 0 in, it would just be equal to 0. So 8/3 is what I get. Now let's do the moment about x. Remember, that's rho integral a to b. The function squared divided by 2 dx. Rho is just 1. My bounds are still 0 to 2. So that's going to be x squared over 2 dx. The over 2, remember, we can pull it out as 1/2. So 1/2 integral from 0 to 2. X squared is x to the 4th. To take the antiderivative of that, remember, add 1 to the power, which would make it x to the 5th, over my new power, which is 5, from 0 to 2. Plug in a 2. 2 to the 5th is 32. If I plugged 0 in, it would be equal to 0, so I don't have to worry about that. 1/2 times 32 over 5. The 32 and the 2 can cancel out to give me 16. So we get 16 over 5 for the moment about x. I'll do the moment about y. Remember, that's rho, integral a to b, x f of x dx. Rho is equal to 1, so it's just integral 0 to 2 of x times my function, which is x squared. X times the x squared is x to the third. Antiderivative of that, I'm going to add 1, which would make it x to the fourth, over my new power, which is 4, from 0 to 2. Plug in a 2. 2 to the fourth is 16 over 4. If I plug 0 in, it would just be equal to 0, so I don't have to. 16 over 4 is 4. So now I have everything that I need to find the centroid. So remember, centroid for x is going to be the moment about y over my total mass. My moment about y we just said was 4. My total mass is 8/3. So 4 over 8/3. Remember, keep, change, flip. 4 is like 4 over 1 times 3 over 8. 4 over 8 cancel out to give me a 2 down here. So I get 3 halves. And then for the centroid of y, we do the moment about x over m. The moment about x, we got 16 over 5 over my total mass, which is 8/3. So 16 over 5 divided by 8/3. Once again, keep, change, flip. So 16 over 5 times 3 over 8. 16 and 8 will cancel out to give me a 2. 2 times 3 is 6 over 5. So the centroid is going to be 3 over 2 and 6/5. Let's do some that are going to require a little bit more work, and let's explain why they do require a little bit more work. Still aren't bad, but just require a little bit more. Example number 7. Let R be the region bounded above by the graph of the function f of x equals 1 minus x squared, and below by the graph of the function g of x equals x minus 1. Find the centroid. So let's talk a little bit about why this one requires a little bit more. First things first, notice it doesn't tell me what the bounds are. So I'm going to have to figure out what those are. And number 2, there are 2 graphs here instead of just a 1. So just like we have done, we did it in section 2.1, we did it in section 2.2, we did it in section 2.3. I'm going to do my top bound, do everything with that, and then minus my bottom bound, okay? So this just requires a little bit more, but it still isn't bad, okay? It's honestly just a lot to write down, not really anything that's too terribly hard. It's just you're writing down a lot of stuff. It's going to use probably 3 of my whiteboards. But again, it doesn't mean it's hard. It's just you're writing a lot of stuff down. So first things first, I don't know what the bounds are, so I can't even start yet. So the bounds are going to be where these 2 graphs are going to meet. So let's see where they meet at. Okay. So to do that, set them equal to each other. So again, I need to know what the bounds are, so I'm going to set the functions equal to each other. The first function is 1 minus x squared, and the second function is x minus 1, right here. So this equation is quadratic because I have an x squared, so therefore I want everything to one side. I like my x squared term to be positive, so I want to move this over to the right side. So let's add x squared and subtract 1, which is going to give me 0 equals positive x squared, positive x, negative 1 minus 1 is going to be negative 2. So now I want to find the factors of the negative 2, whose sum is equal to positive 1. That would be positive 2 and negative 1. So x plus 2, x minus 1. Set both of those equal to 0. And and I get x equals -2, and x is equal to +1. So that's where those two graphs are going to meet. Therefore, those are going to be my bounds. Okay. So for the total mass, remember it's normally rho integral a to b f of x dx. This is a b, not a 5. It looks like a 5. It's a b. But this time I have two graphs, which means I'm going to subtract them in here. Okay. So rho, it doesn't state rho, so I'm going to assume it's equal to 1. My bounds we just found, my lower bound's -2, my top bound is 1. And then for inside of here, I'm going to do my top graph, which said that my top graph is going to be 1 minus the x squared. So 1 minus x squared minus my bottom graph, which is x minus 1 dx. So like I said, it still isn't hard. It's just going to be a little bit more work I'm going to do, but it's not harder work. Let's simplify that by combining like terms. First things first, 1 minus x squared. Distribute my negative. Remember, it's going to be negative x, which would make this positive 1. Combine like terms. Negative x squared minus x. 1 plus 1 is 2. Then find the antiderivative. It's going to be negative. Add 1 here, makes it x to the third over 3. The same thing here, I'm going to add 1, which would make it negative x squared over 2. With a 2, I just get 2x. Doing that from -2 to 1. Plug in my top bound first, so plug in a 1. -1 cubed over 3 minus 1 squared over 2 plus 2 times 1. And then subtract, plug in the -2. So this would make that plus -2 cubed over 3 plus -2 squared over 2 minus 2 times the -2. Work this out. 1 cubed is 1, so this is -1/3. 1 squared is 1, so minus 1/2. 2 times 1 is 2. -2 cubed is -8, so -8/3. -2 squared is 4, so plus 4 over 2. -2 times the -2 is going to be plus 4. -1/3 minus 8/3 is -9/3. -1/2 plus 4 halves is 3 halves. 2 plus 4 is 6. -9 over 3 is -3. -3 plus 6 is just 3. So that's 3 halves plus 3. Common denominator is 2. So that's 3 over 2 plus 6 over 2. 3 plus 6 is 9. So my total mass here is 9 over 2. Once again, I just want to state this again. I've said this a few times, and I will say it a bunch more times. This is going to look harder than it is. So you're going to be tempted to, at this point, see all of this and be like, this looks too hard. I did it wrong. So then, like, you're going to just quit. Don't. Just push through it. You are doing it great. In Calculus 2, there are going to be a lot of problems where there's just a lot to write down, but what you're doing isn't too bad, okay? So don't let it scare you whenever you see something that's like this, and just stop, okay? Keep on. You're doing great. You got this. So my total mass is 9 over 2. Now let's find the moments. I'm going to move this for a second. I'll bring it back whenever we need it. The moment about x, remember, is rho integral a to b function squared over 2. This time I have 2 of them, though, which means I'm going to square each one and then subtract it. Rho is equal to 1, but since it's over 2, I'm going to bring a 1/2 out front. 1/2 integral. We said our bounds were -2 to 1. Do the first function. My top function, again, was 1 minus x squared. minus, then do the same thing for the bottom one, which was x minus 1 dx. And now let's work this out. So this is going to be equal to 1/2 integral -2 to 1. 1 minus x squared squared. Remember, whenever I square stuff, I've got to work it out twice, right? So I'm going to write it twice, times it all out. 1 minus x squared squared is going to be x to the 4th minus 2x squared plus 1. Then do the same thing here. X minus 1 squared. Again, you write it out twice, times everything out. You get x squared minus 2x plus 1. Let's go ahead and combine like terms. X to the 4th, that's the only one here, so just x to the 4th. Negative 2x squared minus x squared gives you minus 3x squared. There's an x right here. Minus negative 2x makes it positive 2x. 1 minus 1, they cancel out, so that's what I have left. So now I'm going to take the antiderivative of that. So 1/2. Add 1 makes it x to the 5th and divide by that power. Plus 1 makes it a 3 over 3 is going to cancel this 3 out, so that's really nice. Same thing happens here, would make it x squared over 2. Cancels out my 2, so that's just x squared from -2 to 1. Plug in our top bound first, which is a 1. 1 to the 5th over 5 minus 1 cubed plus 1 squared. And then subtract, plug in the -2. So minus -2 to the 5th over 5. Minus makes it plus -2 cubed minus -2 squared. That's going to be 1/2 times. 1 to the 5th is just 1, so 1/5 minus 1 cubed is 1, plus 1 squared is 1, minus -2 to the 5th is -32, which would make this plus 32 over 5. -2 to the 3rd is -8, minus the -2 squared is 4. 1/5 plus 32 fifths is 33 fifths. -1 plus 1, they cancel out. -8 minus 4 is -12. The common denominator there is a 5, so that's going to be 33 over 5 minus 12 times 5 is 60. So that's going to be 1/2. 33 minus 60 is -27. Combine those, that's -27 over 10. So I get -27 over 10 for the moment about x. But I still need the moment about y. So let's do that one now too. This is still example number 7. The moment about y, remember, is rho integral a to b x f of x dx. Rho is equal 1. Our bounds are -2 to 1. I have 2 graphs now, though, so I've got to do x times my top graph, which we said our top graph was 1 minus x squared, minus do x times the bottom graph, which was x minus 1 dx. So let's work that out. That's going to be the integral from -2 to 1. X times 1 is x. X times x squared is -x cubed. Minus x times x is x squared. X times the -1 is -x. Combine like terms. Let's see, I have -x to the 3rd. -x squared. X minus the -x is like saying x plus x, so plus 2x dx. Take the antiderivative of that. Add 1 gives me x to the 4th over 4. Add 1 gives me -x to the 3rd over 3. This would be x squared over 2, but there's already a 2 there, so they cancel out. So it's just plus x squared from negative 2 to 1. Plug in 1 first. Negative 1 to the 4th over 4 minus 1 to the 3rd over 3 plus 1 squared minus, plug in the negative 2. So that's going to make that plus negative 2 to the 4th over 4 plus negative 2 to the 3rd over 3 minus negative 2 squared. So that's going to give me negative 1/4 minus 1/3 plus 1. Negative 2 to the 4th is 16. 16 over 4 is 4. Negative 2 to the 3rd is negative 8. So negative 8/3. Negative 2 squared is 4, so that's minus 4. Combine this as much as I can. There's only one with a 4, so negative 1/4. Negative 1/3 minus 8/3 is negative 9/3, which is negative 3. 1 plus 4 is 5, minus 4 is 1. Negative 3 plus 1 is negative 2, so negative 1/4 minus 2. Common denominator there is 4, so negative 1/4 minus 8/4, which gives me negative 1 minus 8 is negative 9/4. So the moment about y is negative 9 over 4. So my centroid for x is going to be the moment about y over my mass. My moment about y was negative 9/4. My mass, go back a few boards ago, my total mass, we got 9/2. Keep, change, flip. Negative 9 over 4 times 2 over 9. Lot happens here, cancel out my 9s. 2 over 4 gives me a 2 in the bottom. So I get negative 1/2. And then my centroid for y is going to be the moment about x over my mass. The moment about x we got was negative 27 over 10. So it's going to be negative 27 over 10 over my total mass, which we said was 9/2. Keep, change, flip. 27 over 9 is 3. 2 over 10, I can put a 5 down here. So I get negative 3/5. So the centroid is at negative 1/2, negative 3/5. So you may ask, why did this one seem like it was way harder than our last one? It is because there are two graphs here, which means I've got to do everything twice, is why. But remember, just because there are more terms and just because there's more I've got to write down doesn't mean it's harder. There's just more terms. Okay, so don't let this scare you. And of course, if anything doesn't make sense, let me know. I'll help you out. One more example in this section. Example number 8, let R be the region bounded above, sorry about that, by the graph of the function f of x equals 6 minus x squared, and below by the graph of the function g of x equals 3 minus 2x. Find the centroid. So do the same thing again. Once again, they don't state what the bounds are, so then I've got to find those first. And then always subtract my top graph minus the bottom graph. So let's do that again. First things first, got to find my bounds, which means I'm going to set the top graph equal to the bottom graph. 6 minus x squared equals 3 minus 2x. Once again, this is quadratic, so I'm going to move everything to one side. So 0 equals, if I move this over there, that makes it positive x squared. Negative 2x doesn't change. If I move my 6 over, I'm going to do 3 minus 6, which is negative 3. So I need the factors of negative 3 whose sum is equal to negative 2. That's going to be negative 3 and positive 1. So my bounds are going to be, because I set both of those equal to 0, x equals 3 and x equals negative 1. So I'm ready to start. Total mass is always rho, integral a to b, f of x dx. Rho is equal 1. My bounds are negative 1 to 3. I have two graphs now, so I'm going to do my top graph minus my bottom graph. Top graph is 6 minus x squared minus my bottom graph is 3 minus 2x dx. So that's going to be integral from -1 to 3. The only x squared I have is negative x squared. The only x I have is negative 2x, which is going to make it positive 2x. 6 minus 3 is 3 dx. Take the antiderivative of that. Add 1 would give me a 3, so negative x cubed over 3. Add 1 would make it a 2. Divided by 2 would cancel out with this 2. So x squared. And then that would just give me 3x. Look at my top bound first. So negative 3 cubed over 3 plus 3 squared plus 3 times 3 minus, plug in my bottom bound. So minus, fixes plus, negative 1 cubed over 3 plus a negative 1 squared. Oh, sorry, subtracting it. So that makes this minus 3 times negative 1 equals 3 cubed is 27. Divided by 3 is 9, so negative 9. 3 squared is 9. 3 times 3 is 9. Negative 1 cubed is negative 1, so negative 1/3. Negative 1 squared is 1, so minus 1. Negative 3 times the negative 1 is positive 3. Negative 9 plus 9, they cancel out. 9 minus 1 is 8, plus 3 is 11. So 11 minus 1/3. Common denominator there is a 3. So 33 over 3 minus 1 over 3 is 32 over 3. So the total mass is 32 over 3. Now I've got to find the moment about x. So moment about x, remember that's rho, integral a to b, the function squared over 2 dx. Since it's over 2, I can bring out a 1/2. So 1/2 integral. My bounds are -1 to 3. Do my top one first. My top graph was 6 minus x squared, minus, do the bottom graph, which was 3 minus 2x. We've got to square both of those. Remember, squaring means I write it twice, right? If you do that and simplify it, you get 6 minus x squared, x to the 4th, plus 12x squared, minus 12x squared, plus 36, minus 3 minus 2x squared is going to be 4x squared, minus 12x plus 9. Subtract those by combining like terms. X to the 4th, that's the only one I have, so that's just x to the 4th. I don't have any x cubes. X squared, I have minus 12x squared minus 4x squared. Gives me minus 16x squared. X, I have negative 12x, so that's positive 12x. Then I have 36 minus 9, which is 27. So now take the antiderivative of that. That's going to give you, I'm trying to decide if I have room right here. I think I do. Add 1 would give me x to the 5th over 5. Add 1 would give me x to the 3rd over 3, so minus 16x to the 3rd over 3. Add 1 makes it x squared over 2. 12 over 2 is 6, so plus 6x squared, and then just 27x from -1 to 3. So plug in our 3 first. 3 to the 5th over 5 minus 16 times 3 to the 5th over 3 plus 6, 3 squared plus 27 times 3. Then minus, plug in a -1, so minus -1 to the 5th over 5, minus makes it plus 16 times negative 1 to the third over 3 minus 6 to the negative 1 squared minus 27 times negative 1. Work all of this out. 3 to the 5th over 5. 3 to the 5th is not something I know off the top of my head. 1, 2, 3, 4, 5. 243. So 243 over 5 minus 3 to the 5th is 243. 243 divided by 3 is 81. So minus 16 times 81. 16 times 81 is 1,296. 3 squared is 9. 9 times 6 is 54. 27 times 3 is 81. Negative 1 to the 5th is equal to negative 1, which would make that plus 1/5. Negative 1 to the third is equal to negative 1, so that's going to be negative 16 thirds. Negative 1 squared is 1. 1 times the negative 6 is negative 6. Negative 27 times the negative 1 is positive 27. And if I worked all of that out, did all the fractions and stuff, all that fun stuff, you end up with 416 over 15. I ran out of whiteboard space, but do this just like we have been doing. And if you need help with it or if it doesn't make sense, you can let me know. I will be happy to help you out. I just ran out of the whiteboard space, so I wanted to just stop. Okay, so now got to do the moment about y. For the moment about y, remember that's rho, integral a to b, x f of x. Rho is 1. My bounds are negative 1 to 3. X times my top graph. Again, my top graph is 6 minus x squared minus x times my bottom graph, which was 3 minus 2x. Let's simplify this. This gives me 6x minus x cubed minus 3x minus 2x squared. That's going to be the integral from negative 1 to 3. My highest power is x cubed. I just have negative x cubed. X squared, I have minus negative 2x squared, which is positive 2x squared. 6x minus 3x is 3x. Take the antiderivative of that. This will give me, add 1 would give me negative x to the 4th over 4. Add 1 plus 2x to the 3rd over 3. Add 1 plus 3x squared over 2 from negative 1 to 3. Plug in my top bound, which is a 3. So negative 3 to the 4th over 4 plus 2 times 3 to the 3rd over 3 plus 3 times 3 squared over 2 minus, plug in the negative 1, so that makes that plus negative 1 to the 4th over 4 minus 2 times negative 1 to the 3rd over 3 minus 3 times negative 1 squared over 2. Work all of this out. I'm running out of time. I only have a minute and a half left of recording time. So to save some time, if you worked all of this out, you get 32 over 3. So for the centroid about x, remember that's the moment about y over my mass. Moment about y is 32 thirds. My total mass we found was also 32 thirds. How helpful is that? 32 thirds over 32 thirds is just 1. And then the centroid for y, that's the moment about x over my mass. My moment about x that we found was 416 over 15. And my total mass was 32 thirds. Keep, change, flip, 416 over 15 times 3 over 32. Simplify that, and you end up with 13 fifths. So the centroid is 1 13 fifths. So once again, this looks harder than it really is. It's just a lot to write down. There's a lot of terms, but the actual math you are trying to do isn't as bad as you would think it is by looking at this, right? But if any of it does not make sense, that's totally fine. Just let me know. I will help out.